Okay. All right. So I'll take it from here then. So thanks again, Dana. Thanks again, Kat, for that awesome demo. So I'm going to talk about something a little bit different. We'll be talking about what we're working on, and that is really the application of generative AI to the problem of design, but sort of a different aspect of design than what we just saw from the HyPark team. So we're really focused on meaningfully transforming really the detailed design process, being able to go from initial concepts, maybe even something very similar to what we just saw, to construction-ready designs in a fraction of the time that it takes today, while also producing much more efficient and cost-effective designs in that process. So I'll cover a couple things today. First, I'll give a bit of a background on why that part of design. Why are we working on this problem? Specifically detailed design. Why is this really the most important part of the overall construction process to apply AI to? I'll talk about what we've built so far, how it works. We'll show a case study of that technology applied to the real world. And then I'll finish off with just some really quick thoughts into our roadmap and the ultimate vision that we're working towards. So very, very quick backgrounder on us. So there's myself, there's Francesco, my co-founder. Obviously, there's a whole lot more really talented folks on our team. But a bit about us specifically. So Francesco, our CEO, initiated the generative design program at Autodesk. I worked with him there to figure out the fundamental UX, user experience principles of those types of design systems. We created Augmenta together to apply those ideas to construction. So what we're doing is we are building autonomous agents that automate the design of core engineered systems, like, for example, your MEP system. So those are the things that are behind the drywall that, as many of us know, especially more on the construction side, really drive up the cost and complexity of building projects. And by automating the design of those systems, we can really speed up that overall design process, make the whole thing a lot more efficient, while also enabling the entire industry to build better, more efficient buildings a lot faster and cheaper than before. So in terms of why we're working on this particular problem, so overall, I know most of the folks on the call know this, construction is the second largest industry in the world, probably the one that on a day-to-day basis has the greatest impact on our lives. It accounts for 40% of global carbon emissions. It's a very critical sector. It's tasked with housing a rapidly growing population, not just in the US, but in Canada, where I am too, and in many parts of the world. But it's also an industry that faces a set of critical challenges. So we've all heard this stat. From a productivity perspective, construction has been essentially flatlined for the last 40 to 50 years. Inefficiency and rework is rampant in that process. In the US alone, $65 billion are spent on rework every year. And all this is compounded by a very severe labor shortage. So everyone on this call is being asked to do a lot more with less. Projects are tighter, margins are tighter, there's more and more risk, and there's less and less people to do the work. So where we're focused is the overall design process. We really believe that there's a lot of challenges within construction overall, but the design process is probably one of the most significant levers that we can work on or try to affect or move to help solve those problems. And when we say design, we're not just talking about the architectural process or the engineering process. For us, it's really every core activity that connects the initial requirements and idea that goes into a building down to the actual construction. So that also means estimation, coordination, detailing, spooling, shop drawings, everything that really connects idea to the field. Those are all the fundamental planning of activities that ultimately are most responsible for the actual efficiency, the actual real world, cost and operation and construction time of a building. So today, that design process, what we see here sort of represented abstractly on the screen, is not productive enough to meet the needs of the industry. That's not the fault of anyone involved. A number of us are trying to solve the problem. HyPar is a great example of that. Fundamentally, buildings are just very hard things to design, and they're very hard to optimize. And one of the problems is that they are designed several times over by a number of different parties as requirements change or information is added through that process. And every time that tweak happens, you have a redesign, a change order. That means cost, it means risk, it means uncertainty, but also means that those parties at the very beginning of the process never had really any way of knowing how much their building would actually cost, how it would actually perform, or how long it would take to build until they're very quite far along in that process. So if we could somehow automate the core parts of this design process and do it in a way where all those considerations of constructability are fully considered from the start, if we could push that information upstream, we can really reduce that uncertainty and really reduce the cost and the waste that comes out of it. So starting to get a little bit more specific on what we're doing about this. So our platform uses a combination of machine learning methods. We synthesize construction expertise and then use it to automate key tasks in that design process. And sort of our angle on this, what's unique about our approach is that we're not just automating some of those preliminary design activities. We're not sort of producing higher level designs that then need to be taken or reworked for coordination or constructability, for example, when it gets into the hand of the contractors. We're actually incorporating field expertise from the contractor level to ensure that we only produce fully constructible and actionable designs from the very beginning. So these are designs that you can actually use to procure, you can fabricate, you can send them directly to a cutter or a vendor or order off of them and ultimately install them. And so what we're ultimately trying to do is, again, take that certainty that you get at the shop drawing level and find ways to push that upstream to when the most critical design decisions are being made in any given project. And as it turns out, working at this level of detail is very complex. It's quite a hard problem, but we've made significant progress on this over the last couple of years. That's what I'll be showing you today. But fundamentally, we're not attacking this whole problem all at once. Right now, we're really focused on the coordination, routing, and modeling of those core systems. So already we can see that using AI in this application does save a lot of time, significantly reduces errors, and is a lot faster overall than doing it manually. So the first agent that we've built is for electrical engineers and virtual design and construction teams. So those teams inside the electrical subcontractors who are taking the higher level specifications and then building out, routing that conduit, adding the couplings, adding supports, converting that into something that will be acted on in the field. We are automating the routing and coordination of those electrical raceway systems. Like I mentioned before, we're really focused right now on the very start of that modeling and coordination workflow. So we take you from a model with no conduit populated to one that is routed, modeled, clash-free, that you could bring into a coordination meeting or otherwise go and act on. The way it works is it takes a set of data points. I'll expand on this in a couple slides, but it takes in a background Revit model. We can take that model from anywhere. It doesn't have to be Revit, but we need effectively a site model. We need to know what we're routing inside. We need to know what we can support off of, penetrate through, and so on. We take a description of what you're trying to connect together in that model. We have design rules. These are your project specifications. Take all that input, and then in a couple hours, generate a number of designs for you to review that are fully routed and coordinated. So we're using this technology already in the real world. One of the case studies I'll be taking you through, or the case study I'll take you through today, was demonstrating the use of this by CNR Electric in a recent project on an elementary school called Mount Hope Elementary. So here they used our tool to automatically route over 11,000 feet of conduit in about 3 to 4 hours. So that's a really good, I think, example of how using AI this way can really optimize what is today a very complex and tedious task that requires extensive manual effort, ultimately getting you to a faster, more reliable design process. So what I'll do is I'll show you a quick video. I'm going to hop out of the presentation to do that because it'll run a little bit more smoothly. Just give me a second here.
The level of sophistication that we have is miles ahead of anyone that I've heard of doing something, anything like this.
We used ACP to run all of our conduit, and the guys are down here now on site installing all of it. Augmenta is going to be the piece that, instead of spending hundreds of hours drawing conduit down corridors, it's going to generate your paths for you. So it's just the next logical step to get fabrication out the door faster and hopefully more accurately.
Everything that's on these pipes, like the labels and whatnot, the circuits, is all populated and put into place by the ACP.
Oh, wow. It gives us a competitive advantage. We know the entire infrastructure.
It's doing it for you. It's very simple to use.
Okay. All right. So let's go ahead and talk a little bit more about, just skip that. Let's talk a bit about the performance, as in how well does it actually work? That's going to be on everyone's mind for sure. So a bit of framing here. We at Augmenta, really think of ourselves almost like a self-driving car company, and that's actually how we operate ourselves internally. We're not doing self-driving cars, we're doing self-driving BIM or self-driving design. So our goal and how we measure our progress is we want to reduce the amount of human intervention in the designs our system produces over time. Meaning that as time goes on, a human being can produce more and more design work in the same amount of time. In a self-driving car company, that's your interventions per mile. How many times do I have to go and take over? In our case, it's how many times do I have to go in and make a modification to something that our system produced. We've made really significant progress in the performance of our system, but it's not yet producing perfect design. So here's an example of what that looks like in practice. This was on that CNR project. So what we output is here on the left. What we can see then is that CNR made some changes here, right? So they adjusted the elevation of the rack. They adjusted here some of the layout of these conduits. Later on in the project, they added a few more conduits, so they didn't use our system to regenerate the entire design. We got them 80–90% of the way there, and then afterwards, we're outputting a generic Revit model, so it's very easy for them to make slight modifications on top of that. And then we can see the final installation there on the right. So today, what we're really doing is we're taking folks to, again, that 80 or 90% stage, and we're measuring our progress in reducing that amount of intervention required so that eventually we'll get to that 100%. So internally, we really measure the performance of our system with this productivity metric. In the last 12 months, we've increased that productivity by 10x. Early this year, around April, we surpassed human productivity. So that was when we got past that 1x threshold. And of course, then we've grown significantly since then. And that rate of increase is growing. So certainly in the next 12 months, we really expect to see very significant improvement. And then, of course, in the future, we'll be moving on beyond just electrical, but I'll talk about that in a second. Okay, so let's talk a bit about how it works. What does it actually look like to use our system? So very quickly, I'll go through this at a high level. The workflow is broken down into 3 steps. So first thing that you're doing is you are inputting that data. I already talked about this a little bit in a previous slide, but essentially you're giving it everything it needs to know or understand about a problem to solve for it. So that means I'm giving it a Revit background or some form of site geometry. It needs to understand what it's coordinating around, what it can support off of, penetrate through, and so on. There's different preferences I might have about, oh, I'd prefer if you ran down this corridor, if there's enough room. I don't want you running through here. So you're marking up a model with this type of input. You're describing the things you want connected. You're describing your project specifications in terms of supporting methods, clearances, things like that. Once you've set all that up, you hit generate. The system will then go and generate a number of designs on your behalf. Each of these designs are costed we have a cost and labor evaluations for any design produced. So on its own, it's sort of on your behalf trying to produce a divergent set of solutions. It's trying to show you what are the things that I can choose between on this project. Maybe I want to optimize for the design that costs more but can be built more quickly, or vice versa, depending on the needs of that project. Once those designs are generated, you can export them into Revit. So we're just exporting, for now, this design as generic Revit conduit. It will look just like something that your own BIM team would have produced themselves, and it's very easy then for them to detail it out, modify it, add their own information to it, but we're really just trying to integrate very seamlessly into the way people work today. All right, so where are we going next? The ultimate vision that we're working towards is a platform that automates multidisciplinary building design. So everything from the MEP systems to the structural systems, even some aspects upstream of that. Really, we want to be delivering optimized construction-ready designs at the click of a button. This is really a fundamental step change or a shift in how we think about the way buildings are designed and constructed. And philosophically, we kind of think of this as a return to the concept of a master builder. It's this return to this sort of mythical time when buildings were designed by individuals or very small teams who intimately understood every aspect of how a building came together. And that's really what we're trying to do here. We want to democratize the process of design at that level so that architects, engineers, contractors can very rapidly design and iterate and ultimately optimize all of these different systems together with full confidence of the constructability, knowing that every nut and bolt consideration of procurement, fabrication, installation is designed every time I even begin to sketch out a building, not 3 or 6 months down the road. So we're approaching this in steps. We're starting off with the design of electrical systems. Next up, or now, we are kicking off the development of mechanical and plumbing systems, and we're not going to be just automating those independently like what I just showed you now, but designing each of those concurrently. So everyone specifies requirements, and we're producing these fully coordinated, fully considered MEP systems where everything is known to fit and can be optimized for higher level project goals. So in summary, what we're really trying to do is build a future where buildings are designed the same way a microchip is designed today. We're aiming to really fundamentally rethink how design and construction works together, how it happens, because we want to be able to help everyone build better, faster, and with a lot more precision and certainty. So we think this is a very interesting problem to be working on and to try and solve. If you find what we're doing interesting, I hope that you'll reach out. Best way to reach us is actually via the email that you see up on the screen here. So that's for our VP of Growth, Matt, who's also on the call. But I'll leave it there and thank you for your time.
Thank you. And since we have a few minutes, Aaron, there are a few questions. How are requirements inputted to the platform, like Excel? And how would you define where the system can run, not run, penetrate, etc.?
Sure. Yeah. So a lot of it comes out of Revit. So just getting into details in Revit, I have my structural, architectural, anything I need to coordinate around is linked into Revit. So that's my starting point. I have my electrical equipment that I have placed, like you as a user have placed. That panel is going to have a panel name. You provide a separate run schedule that simply just describes this panel connects to this junction box and so on. So you're providing all of that information around where your preferences in terms of routing. We have a Revit plugin that you use to mark up the model, and you're basically drawing out different spaces and volumes that have different sort of meaning associated with them. It's a lot more intuitive when you see it, but basically you can just sort of mark up your model in 3D and you're illustrating, okay, this is a preferred space, so we'll try to bias the route through here. This is a keep out, so I don't want to route anything through here unless it's to hit something in this room. So we have a fairly intuitive workflow of being able to mark up that model with those preferences.
Fantastic. And Kat, since we had so many questions there, is there anything that maybe you wanted to wrap up or let the users know before we jump off?
Just start. You can try it. It's free for 3 projects. And I know I've touched upon it being useful for healthcare and workplace, but of course you can use it for a variety of different things. And in fact,
get
people
the
have
Revit add-in, right? It's free. So yeah, I've put the links both for Augmenta as well as Hypar in the mural under the left side under the presentation information, so you can get to those very easily. And of course, reach out to Aaron and Kat if you guys have any questions. Thank you guys so much for your presentation today. I feel like you both probably could have filled the whole session today. So thank you so much for giving us with this information. And thank you all, of course, for joining us.